So hey everyone, welcome back and I hope you are doing well. So today we are going to discuss another LeetCode contest, and this one is weekly contest 500. So this is great, right? So today contests question are really good. Like I won't say that these are too difficult, but these are really good problem. Like it teaches you a lot, and some are pretty easy. So yeah, the contests are pretty good. So let's start with the first problem. Like what the problem statement states. Okay, so the problem is you are given an integer array nums of length n. Okay, the score of index I is defined as the number of indices j such that I should be less than j, and nums I and nums j have two different parity, which means one is even, another is odd. So return an integer array answer of length n, where answer I is the score of index I. Got it? So what we have to do, we just have to check like at the 0th index we have odd number, and thus the indices 1 and 2. Like at every index we just have to check from I plus 1 to till n minus 1 how many different parity like different parity value elements are there in our array, and the count of those elements are going to be a score of our current value. So what I am talking about is, let's take an example of this. Okay, so this is my array, and my nums of it is nums of 0, which is 1 and odd number, right? So and what I have to count, I have to count the score, and how the score is going to calculate it, the number of different different parity bit elements, right? Those have different parity bits. So like what are those elements? So if we have a current element as an even element, then the element which have a different parity is always going to be odd even number, and same case for even, it is odd, right? So we just have to count the even numbers from I plus 1 to till n minus 1. So this is what we have to achieve for the current ith index, and this operation we have to perform for every indices which we have, right? So what's the brute force approach is look like? Simply iterate from 0 to n, right? And after that I just start from j plus 1 and j less than n, j plus plus, right? And at every point what I have to check, I will just check like through boolean value, is even or not, right? It's even. If it is like, I will simply check if nums of I is like even or odd, right? It will tell me that okay, the number is even or odd, right? If is even and current nums j is not even, right? In that case we simply count, right? We simply increment for the current indices and use it inside our answer, right? But if you see the code, you see it is, we are running two different loops, and which are going to produce you a time complexity of O of n square, which is not a good approach for this particular problem, right? Because we here what's the main goal, right? The main goal is just to get a count, right? So instead of counting every time, what if somehow we pre-calculate all the stuffs and simply use it whenever we want, right? So there is two way, either you can start from the front, either you can start from the back. So what you can do, first count number of even, and then count number of odd, right? At every position you just have to check if it is even, then store the if it is even, then store odd count, and if it is odd, then store even count. And make sure based on the current element type, just simply either decrement odd or decrement even, right? So this is what we have to do in this particular problem. So what I have done, I have did it from the back, I just explained you from the front. So what I am doing over here, so that I don't need to run two different loops, I'm just using the single loop. So I'm iterating from the back, and I'm just checking if the current element is even. If it is even, then I'm simply storing the odd count, because what exactly I want. And if it is an odd number, then I'm just storing the even count. And make sure that if it's even element then increment even count, otherwise odd count. So this is the whole problem is look like, and this is the optimal approach, right? This will work if the value of constraints are pretty high, right? So yeah, the time complexity is over fine, and this is a pretty easy problem. So let's move to the second one. The second problem is it is also pretty easy. Sum of primes between numbers and its reverse. So what they are saying that you are given an integer nums. Let r be the integer formed by reversing the digit of n. Return the sum of all prime number between minimum. Okay, a prime number is a natural number that number greater than 1 with only two factor 1 and itself. Okay, got it. So what they are saying that initially we have a value as n, right? Let's say some other value, like have some value, right? And we have to calculate the reverse of n, reverse of n, and between n, from n to reverse, I'm just assuming that reverse is greater, right? We just have to check how many prime numbers are there, and just simply store there, like I just simply have to add that number inside our answer. So this is what we have to do. We just have to do whatever the problem is asking to us. And if you see, the constraints are pretty low, right? It's just 1000, right? So which is actually pretty low. So what you can do, you can just simply reverse the number, and from n to till that particular reverse number, you just have to iterate and just check if it's a prime or not. And if it is not, then simply if it is a prime number, then simply store inside your answer, right? So this is what you have to do. So it's a pretty, like whatever I am telling you right now is a brute force approach, but it will also work fine because the constraints are pretty low, right? And what about the optimal approach if the constraints are like, because I also read about the people, because it help you a lot. So someone suggesting that it should be an 1 in a power 5 at least, because there is no sense of making this problem medium if the constraints are pretty low, right? So that's what people are suggesting. So I am just thinking in terms of medium problem. So what I did, so this is the code which I have written. So what I have done, I just have pre-calculated the prime numbers, and you know there is a famous Sieve algorithm which you can use. If you don't know, then go to the YouTube, search about Sieve algorithm, you get a lot of other videos. And if you want me to explain, then do let me know in the comment section. I will love to make video on that as well, right? So you just have to I just calculated the prime. And how I calculated, this is the standard like Sieve algorithm, where for the current element we are just marking false to all these factors, so that those are not going to be used, because prime number is a number which is only divisible by 1 in itself. Once it is done, we are just simply iterating from I to that particular max and checking if it's a prime. If it is, then simply adding to our answer, otherwise returning it. And here is our reverse function look like. If you run it, so this is the like this is working absolutely fine. So this is about the today contest. First and the second problem, these are really good, really easy, not that much difficult. But for the second problem, if the constraints are pretty high, then it is not be easily acceptable by a lot of people if you don't know about Sieve algorithm. So do learn about Sieve algorithm, that help you a lot in such problems. And whenever you see a statement like prime and you have to calculate prime, then always think about Sieve algorithm, because it is the only thing which actually help you to reduce the complexity of the problem. So this is it for the video, and I hope you like the video. If you are able to understand it, do let me know in the comment section, share your thoughts. I love to hear your feedback as well. And this is it for the video, and bye bye, take care.